Now moving to the next type of questions when we have power as fraction, which is we have question 17 and 18. So let's try to solve question 17. So in question 17, starting with finding the domain. Now be careful in here, we can find or write the function another way since we have a negative power. So this is x to the power 4 over 3 plus 4x to the power 1 over 3 plus 4 over x to the power 2 over 3. So in here, for this, since the denominator is the index of the root, we have odd root and odd root, which is a 3 root from the index 3, which is odd. So in here are, but in here we have undefined value, which is the 0. If the denominator is 0 in here, then it will be 4 over 0, which is undefined. So that means in here the domain is r minus 0. Okay, so now I'll start finding the derivative after finding the domain. So I'll find the derivative for this, which is easier. So it will be 4 over 3 x to the power 4 over 3 minus 1, which is 3 over 3, which is 1 over 3. Then plus 4 multiplied by 1 over 3, which means 4 over 3, x to the power 1 over 3 minus 3 over 3 or 1, which is equal to minus 2 over 3. Then minus, because I will have minus from this power, minus 2 over 3 multiplied by 4, which is 8 over 3. Then x to the power minus 2 over 3 minus 3 over 3 or 1. This is equal to minus 5 over 3. Now I will take the x with the least power as a greatest common factor, which is x to the power minus 5 over 3 outside, and also we can take a greatest common factor as 4 over 3 outside actually. So 4 over 3 outside with x to the power minus 5 over 3. So multiplied by, in here I will have 1 x to the power 1 over 3, let's take them over here, x to the power 1 over 3 divided by x to the power minus 5 over 3, which is dot x to the power 5 over 3. So in here, this is equal to x to the power 6 over 3. Now, x to the power 6 over 3, which is x to the power 2. So, x to the power 2 plus 4 over 3 outside, which is 1, x to the power minus 2 over 3 dot x to the power 5 over 3. 5 minus 2, which is a 3, so 3 over 3, which is 1. So this is x to the power 1 minus, now I took 4 from the 8, which means I have 2 over here, and I took the 3 outside, and x to the power minus 5 over 3 outside. Now let's make the derivative equal to 0, okay, and let's factorize this. So if I would like to write them correctly, 4 multiplied by the factors from this. You can factorize it manually, which is I need two numbers, their multiplication equal to minus 2 and their summation equal to 1, or you can use your calculator. Let's see how we can use the calculator. So directly to the calculator, AC, so menu, then A, then polynomial from the second degree. I will put the coefficients 1, then 1, then minus 2. So I have 1 and I have minus 2. Be careful once you write the coefficients. They give me in the calculator minus 2 and 1. So I will write them as x minus 1, x plus 2. If you are writing them as factors like this, you have to give them the opposite sign. If you are writing them as solutions or zeros at the end, then take them with the same sign. So over 3 multiplied by x, if we want to take this downward, it will be positive 5 over 3, now equal to 0. Now from the numerator, I will get x equal to 1 and x equal to minus 2. These are the zeros. And the undefined value from the denominator, x, from making the denominator equal to 0, x to the power 5 over 3 equal to 0, that will give me x equal to 0 directly. Now, let's check if they are included or not. For the 1, it's included. For the minus 2, it's included as well. Now for the 0, it's rejected because it's not included in the domain of the original function. So now all I have to do is just finding the local maximum and minimum. So I will take this, graph the number line, put the values, even the 0, you should put it just in case. Now we are not going to take it as a local maximum or local minimum, just we want to put it. So in here I have minus 2, in here I have 0, and in here I have 1. In the next videos, inshallah, I will tell you how or why I took the 0 and I put it on the number line. So after that, let's check the sign of the derivative, sorry. So let's see this. So I have okay, menu 1, and let's write the function or the derivative 4 multiplied by x minus 1, okay, then multiplied by x plus 2, so alpha x plus 2, and close this. Then downward I have a 3 multiplied by x to the power yes, 5 over 3, 5 over 3. This is my derivative. Okay, so now let's substitute any value less than minus 2. Let's say I have minus 3. Let's choose yes. I have minus, so a negative first of all. Then what about a value between minus 2 and 0? Let's say minus 1. Okay, let's go back. Okay, calc. Minus 1. Okay, we have positive. So the first one is negative, the second one is positive, so negative, positive. Okay, so let's calculate it in another value greater than 0. Let's say 1. No, no, not 1. It's between 0 and 1, 0 0.5. Okay, that will give me a negative value. So negative, positive, and here, so negative, positive, negative. Okay, then let's see another value greater than 1. Let's say 2. Okay, 2 is positive. Okay, so I have in here positive after the 1, before the 1 is negative, positive, negative, then we have positive, then we have negative. Okay, so I have negative, positive, negative, positive. Okay, so it's downward, up, down, and up. Be careful, I cannot take the 0. Okay, I cannot take it as a local minimum. So in here I will choose minus 2 and 1 because they are included in my domain. So local minimum at x equal to minus 2 and 1. No local max. Be careful. That's it. This is the end of this question 17. So now still we have two types of questions. If we have square root, and I prefer to solve this question actually, which is included by square root in the denominator, And in here, absolute value function, how to solve it. This is easy, I think, because we have odd root, sorry. So that's easy. So next video, inshallah, we'll talk about these questions.